Welcome! This is Programming Concepts. I'm Leo, and today I'll be talking about the fundamental data types. First, what is a data type? All data stored in computer memory must have a type, otherwise a program would not be able to know how to handle it. This is similar to how data is useless on its own unless we have context. I would recommend you watch the video on this if you want further information, which is linked in the description. Starting off with the Boolean type, which may also be referred to as bool, it is the simplest data type having only two possible states, either true or false. If you know binary, this may seem familiar to a single bit, which can be either 1 or 0. This is actually because Booleans are actually stored internally as a single bit. Taking a look at this example, how could we convert this to use Boolean types and be more machine friendly? If it's raining outside, then bring an umbrella. Using Booleans to make this more machine friendly, we could get a result such as shown. If is raining equals true, then bring an umbrella. So if it's raining, the state would be represented as true, meaning we would bring an umbrella. However, if it was not raining, the represented state would be false, resulting in us not bringing an umbrella. This form of writing is actually called pseudocode, which is used to express the steps required in a program. This will be covered in a future tutorial. Moving on to the next data type, the integer, which is commonly called the int. This type stores whole numbers, which can be negative or positive. If you're unsure what a whole number is, it's actually simple. It's just a number without a decimal point. Taking a look at this example currently shown, where do you think an integer has been used? I am 18 years old and I'm currently 175.1 centimeters high. If you thought 18, you'll be correct, since 175.1 is not a whole number, since it has a decimal point. We now know how to represent a whole number, but what happens if we need to represent fractional numbers? Well, we have a specific data type to handle those as well, the real or floating point, which is also known as float. Like integers, a real can be negative or positive. However, instead this time they can store a decimal point. Taking a look at the similar example as before, can you spot where a float has been used? I am 18 years old and I'm currently 175.1 centimeters high and my score is 5.0. If you spotted 5.0 and 175.1, you would be correct. But why is 5.0 a float? Although we'd interpret it as being a whole number, a computer program would read it as a float since the decimal point is shown. But what about 18? This is still an integer, as no decimal point has been written. In some programming languages, decimal may also be another data type that can store fractional numbers. However, this type is not being covered in this video. Moving on from storing numbers, how can we store text? Or more specifically, characters? Storing text in programs are stored in the character data type, also known as char. This allows for a single alphanumeric character to be stored. Alphanumeric simply means that we have A to Z in lower and uppercase, or numbers and symbols such as percent or semicolon. Here's some examples of characters. Capital A, lowercase h, 1%. Notice how we've wrapped each character in a single quote. In most programming languages, this is how we represent a character type in code. In computer programs, characters are stored and represented in something called an encoding format. Generally, one of the two different standards are used, either ASCII or Unicode. Following on from the character type, the string type, also known as str, is used to represent one or many characters, also known as a sequence. Here's some examples. Capital A, lowercase b, c, 1, 2, 3, 4, plus. Notice this time we've wrapped them in double quotes. Like before, this is how we represent them in code. However, this time we're indicating that they are strings. We have now covered the fundamental data types in computing. However, what happens if we need to convert between types? This would require a process called typecasting. For example, if we wanted to convert a string, 42, into an integer, we would need to cast the value. In the Python programming language, we would write the following code. Int brackets string 42. After it has been cast by the computer, it would result in the value being converted to 42 as an integer. How about turning the float 9.5 into an integer? And again in Python, int brackets 9.5 and then a closing bracket. However, this time our result will be 9. We've lost some data. This is some important information to know about typecasting. Depending on what type we are casting from and into, we may lose some data. Our programs can even crash if this is used incorrectly. You may be asking why we need typecasting. In some circumstances, certain pieces of our code will require a specific type. For example, if we wanted to perform some mathematical operations on a string, we would first need to convert it into either a float or an integer type. We might also be using some code that is not under our control that may expect a certain data type to be used. In conclusion, this video has covered the fundamental data types and an introduction into typecasting. You should now know the differences between the data types, what typecasting is, and why we might need to use it. If you found this video useful, leave a like and subscribe for more related content. A written version of this video is also available on the Enchanted Code website, which is linked in the description. Hope to see you next time. Bye for now.